Close your eyes now. Take a slow, deep breath. Feel the air fill your lungs, then gently release. In this moment of stillness, something extraordinary is happening. Something so small, so invisible, that you cannot see it or touch it. Yet it surrounds you completely. You are floating in an ocean of particles. Tiny, dancing specks of energy that make up everything you know. Your pillow. Your blanket. The air you breathe. Even you. These particles are smaller than anything you can imagine. If an atom were the size of a football stadium, the nucleus at its center would be no bigger than a marble. And the electrons spinning around it? They would be smaller than grains of sand. Yet within this vast emptiness, magic lives. Your body contains more atoms than there are stars in the observable universe. 60 trillion cells, each one a bustling city of molecular activity. And every single atom in your body was once part of something else. A distant star. A floating cloud of cosmic dust. The breath of a dinosaur from millions of years ago. You are made of stardust. Literally. The calcium in your bones was forged in the heart of an exploding star. The iron in your blood was created when massive suns collapsed billions of years ago. The oxygen you breathe right now has traveled through countless lungs before finding its way to yours. This is not poetry. This is science. This is your story. But there is something even more mysterious happening in the spaces between your atoms. Something that would puzzle the greatest minds in history. Something that seems impossible, yet happens billions of times every second. Particles are talking to each other. Not with words or sounds. Not with signals that travel through space. They communicate instantly, regardless of distance. They share information in ways that seem to break the rules of everything we thought we knew about the universe. Imagine two coins, one in your left hand, one in your right. In our everyday world, flipping one coin has nothing to do with the other. But in the quantum world, these coins would be connected. Flip the left coin and it lands on heads. Instantly, without any delay, the right coin will land on tails. Always. Every time. No signal passes between them. No force connects them. Yet they know each other's fate in a way that transcends space and time. This is called quantum entanglement. And it is real. Right now, in your body, particles are entangled with particles in the farthest reaches of the universe. The boundary between you and everything else begins to blur when you peer into this hidden realm. Scientists call this the quantum field. It is not empty space, as it appears. It is alive with possibility. It buzzes with potential energy. It connects everything to everything else in ways we are only beginning to understand. When you dream tonight, your thoughts arise from electrical signals jumping between brain cells. These signals depend on the movement of electrons. And electrons, as it turns out, behave in ways that would seem like magic to someone from 100 years ago. An electron can be in two places at once. It can spin in both directions simultaneously. It exists in what scientists call a superposition, a ghostly state of being all possibilities at the same time. Only when we try to measure it, to pin it down, does it choose to be one thing or another. The very act of looking changes what we see. You are not separate from this quantum mystery. You are part of it. Every breath you take involves billions of quantum events. Every heartbeat depends on particles that dance according to rules that Einstein himself called spooky. Tonight, as you drift toward sleep, your consciousness will journey through states that mirror the quantum world. Neither fully awake nor fully asleep, but somewhere in between. A superposition of awareness, floating in the space between dreams and waking. The boundaries of your body, so solid and real during the day, will soften. You will expand beyond your skin, beyond your room, beyond the earth itself. In sleep, you return to the quantum field from which you came. This is not imagination. This is the deepest truth science has revealed about the nature of reality. You are not a separate being moving through empty space. You are a temporary pattern of energy, connected to everything that was, is, and will be. The pillow beneath your head contains particles that remember the formation of galaxies. The blanket that covers you holds atoms that witnessed the birth of the first stars. You are surrounded by history. You are made of history. And somewhere, in laboratories around the world, scientists are learning to harness this quantum mystery. They are teaching particles to disappear from one place and reappear in another. They are unlocking the secrets of instant connection across impossible distances. They call it quantum teleportation. The word itself sounds like science fiction. Like something from a movie or a dream. But it is happening now, in our world, in our time. And it all begins with understanding the whispers that pass between particles in the quantum field. As your breathing slows and your body relaxes, feel yourself sinking into this deeper reality. You are not just lying in bed. You are floating in an ocean of possibility, connected to everything through invisible threads of quantum entanglement. Tonight, you will dream with stardust. You will think with particles that remember the beginning of time. And somewhere in the gentle rhythm of your sleeping breath, the universe will whisper its secrets to you. But there was once a man who found these whispers deeply troubling. A brilliant scientist who changed our understanding of space and time, yet could not accept what the quantum world was telling him about the nature of reality. Picture a man with wild, silver hair, sitting alone in his study. The year is 1935. Outside his window, the world moves at the speed of horses and trains. Inside his mind, thoughts race at the speed of light. This man is Albert Einstein. And tonight, he is troubled. For 30 years, he has been humanity's guide to the deepest mysteries of space and time. He showed us that time can slow down. That space can bend. That energy and matter are the same thing, wearing different faces. But now, quantum mechanics is whispering something that makes him deeply uncomfortable. Something that challenges everything he believes about how the universe works. Let yourself drift back to that quiet evening. Einstein sits at his desk, pen in hand, trying to solve a puzzle that has no easy answer. The puzzle of connection across impossible distances. Earlier that day, his colleagues had described something extraordinary. They spoke of particles that could influence each other instantly, no matter how far apart they traveled. Not almost instantly. Actually instantly. Imagine throwing two stones into a perfectly still pond. In our everyday world, the ripples from each stone spread outward separately. They might eventually meet, but each stone creates its own pattern. In the quantum world, it would be as if the two stones were somehow the same stone. Touch one, and the other responds immediately, even if it lies on the other side of the ocean. No ripples travel between them. No time passes. The connection simply exists. Einstein called this spooky action at a distance. The words taste strange in your mouth, don't they? Spooky. As if the universe itself had become a ghost story. He couldn't accept it. It violated everything he knew about the speed of light being the ultimate speed limit. Nothing, he believed, could travel faster than light. Information, influence, connection, all of it must respect this cosmic speed limit. Yet the mathematics of quantum mechanics insisted otherwise. Close your eyes and imagine Einstein's frustration. Here was a man who had unlocked the secrets of gravity, who had shown us that massive objects bend the fabric of space itself. Yet these tiny particles, smaller than the smallest speck of dust, were defying his most sacred laws. He spent sleepless nights trying to prove that quantum mechanics was incomplete. Surely, he thought, there must be hidden variables. Secret messengers traveling between particles at light speed or slower, carrying the information that creates this illusion of instant connection. He wrote papers with colleagues, proposing thought experiments to show that quantum mechanics couldn't be the whole story. The most famous became known as the EPR paradox, named after Einstein and his collaborators Podolsky and Rosen. Imagine their thought experiment as a simple story. Two particles are born together, like twins sharing the same crib. Then they are separated and sent to opposite ends of the universe. According to quantum mechanics, measuring one particle should instantly determine the properties of the other. Einstein argued this was impossible. The particles must have predetermined properties, like secret instructions written in their quantum DNA. The measurement doesn't create the connection, it simply reveals what was always there. But he was wrong. And oh, how beautifully wrong he was. Decades later, scientists would perform real versions of Einstein's thought experiments. They would create pairs of particles and separate them across laboratories, across cities, across continents. And every time, without exception, the particles would behave exactly as quantum mechanics predicted. Measure one particle's spin, and its distant twin would instantly know to spin in the opposite direction. Change one particle's energy state, and its partner would immediately respond, as if they shared the same quantum heartbeat. The connection was real. Instantaneous. Undeniable. Einstein had given science a gift without realizing it. By questioning quantum mechanics so deeply, he had pointed the way toward one of the most remarkable discoveries in human history. The discovery that would eventually lead to quantum teleportation. Tonight, as you rest in the darkness, feel the presence of those countless particle pairs dancing around you. In the air you breathe, in the walls of your room, in the very atoms of your body, quantum twins are maintaining their mysterious connections. Some of these particles were entangled when the universe was young, when galaxies were first taking shape. They have traveled billions of light-years apart, yet they remember each other perfectly. They respond to each other's changes as if no distance existed between them. This is not magic, though it feels magical. This is not science fiction, though it sounds impossible. This is the deepest truth about reality that we have discovered. The universe is not made of separate things. It is made of connections. Einstein spent his final years searching for a theory that would unite all the forces of nature. He called it the theory of everything. He never found it. But perhaps he was looking in the wrong place. Perhaps the unity he sought was not in equations or formulas, but in the spooky connections that troubled him so deeply. Perhaps the universe is already unified, and we are just learning to see the threads that bind everything together. The lamp beside your bed contains particles that are quantum entangled with particles in distant stars. The breath you just took includes atoms that are mysteriously connected to atoms in far-off galaxies. You are not separate from the cosmos. You are woven into its very fabric. Einstein's spooky action surrounds you, embraces you, flows through you. And in laboratories around the world, scientists are learning to use this spookiness for something that would have amazed even Einstein himself. They are learning to make information disappear from one place and reappear in another, carried not by radio waves or fiber-optic cables, but by the ghostly connections between quantum twins. As your breathing slows and your thoughts begin to wander, imagine those first entangled particles, born together in some ancient cosmic event. One traveled to your pillow tonight. The other journeys still through the deep space between galaxies. Yet they remain connected. They remain one. And in that oneness lies the secret of teleportation itself, the mystery of how two particles, no matter how far apart, can dance together as if they had never been separated at all. In a quiet meadow, on a warm spring morning, something beautiful happens. A silken cocoon trembles on a branch. Inside, two butterflies are about to be born. They emerge together, wings still damp from their transformation. For a moment, they rest side by side, sharing the same ray of sunlight. Then a gentle breeze carries one toward the eastern hills. The other drifts west, toward distant valleys. Miles apart now, they flutter through separate worlds. One dances over daisies. The other sips nectar from mountain wildflowers. Yet somehow, in ways we cannot see or measure, they remain connected. When one turns north, the other turns south. When one rises high, the other flies low. They are entangled souls, forever part of the same story. This is how quantum entanglement works in the invisible world of particles. Two tiny bits of matter, born from the same quantum event, become forever linked. No matter how far they travel, no matter what stands between them, they remember each other. Take a slow, deep breath. Feel the air enter your lungs. Among those billions of oxygen molecules are particles that were once entangled with particles now scattered across the galaxy. You are breathing stardust that remembers its quantum twin, somewhere in the vast darkness of space. Scientists first discovered this mysterious connection by accident. They were studying light, trying to understand how photons behave when they encounter crystals. What they found changed everything we thought we knew about reality. When certain crystals are struck by laser light, something magical happens. The crystal splits a single photon into two identical twins. These twin photons fly apart in opposite directions. But they carry with them an invisible bond that defies all common sense. Imagine holding two magical coins. No matter how far apart you take them, when you flip one and it shows heads, the other will always show tails. Not sometimes. Always. As if they share the same quantum heartbeat. This is exactly what happens with entangled photons. Measure the spin of one, and its twin instantly knows to spin in the opposite direction. Change the energy of one, and its partner immediately responds, as if they were still touching. But how is this possible? How can information travel faster than light? How can particles separated by millions of miles influence each other with no delay? The answer lies in a truth that feels almost too beautiful to believe. The particles never actually separated. In the quantum world, they remain one being, wearing two faces. Like a river that splits around an island but remains the same water, entangled particles are one quantum system expressing itself in two places. You experience this connection every day without knowing it. The calcium in your bones was created in the heart of an ancient star. When that star exploded, it scattered calcium ions across space. Some of those ions eventually became part of you. Others became part of distant planets, other stars, other worlds. Yet they remember their origin. They remain quantum connected to their scattered siblings. Your bones are linked to the bones of creatures on worlds you will never see, through invisible threads of entanglement that stretch across the cosmos. Right now, as you rest in the comfort of your bed, trillions of entangled particles flow through your body. Some were paired in the first moments after the Big Bang. Others were born in the nuclear fires of stars that died before our sun was born. They carry messages written in the language of quantum mechanics. Messages about the fundamental unity of all things. Messages that say, nothing is truly separate, everything is connected, and the boundaries we see are gentle illusions. Scientists have learned to create entangled particles on purpose now. In laboratories around the world, they birth quantum twins using lasers and crystals and careful manipulation of light. They separate these twins by inches, then feet, then miles. And every time, the connection holds. Measure one particle in New York, and its twin in Tokyo responds instantly. The Earth itself cannot break the bond between quantum souls. This discovery has practical magic hidden within it. If particles can share information instantly across any distance, then perhaps information itself can be teleported. Not copied or transmitted, but actually moved from one place to another without traveling through the space between. It sounds impossible. Yet in quiet labs, scientists are already doing it. They take the quantum properties of one particle and make them appear in another particle far away. The information doesn't travel through wires or radio waves. It travels through the mysterious connections of entanglement itself. Your dreams tonight will be filled with quantum twins dancing their eternal dance. In your sleeping mind, boundaries will dissolve. You will float in a space where connection transcends distance, where touching one thing touches everything. This is not imagination. This is the deepest truth science has revealed about the nature of reality. At the quantum level, separation is an illusion. Everything that exists is part of an infinite web of connection, woven from the threads of entanglement. The pillowcase against your cheek contains particles that are quantum linked to particles in the Andromeda galaxy. The air you breathe holds atoms that remember their entangled partners in the heart of distant suns. You are not alone in the universe. You are connected to everything through invisible bonds that can never be broken. As sleep approaches, feel yourself becoming part of this cosmic dance. Your consciousness, arising from the electrical signals in your brain, depends on particles that obey quantum rules. In dreams, you join the eternal waltz of entangled souls, spinning together across the infinite ballroom of space and time. But entanglement is only the first step in the quantum magic of teleportation. For information to truly disappear from one place and reappear in another, something even more mysterious must happen. Something that transforms the very meaning of communication itself. Imagine standing on a quiet beach at sunset. You write a message in the sand, then watch as the waves gently erase it. But somehow, on another shore thousands of miles away, that same message appears in the sand, written by invisible hands. No bottle carried it across the ocean. No bird flew it through the sky. The message simply existed in one place, then existed in another. This is the mystery of quantum communication. In our everyday world, messages need messengers. Your voice travels through air as sound waves. Your text messages flow through cables and cell towers. Light carries images to your eyes. Everything follows a path from here to there. But in the quantum realm, information can move without moving. It can disappear from one particle and appear in another, with nothing traveling between them. No signal crosses space. No energy makes a journey. The information simply ceases to exist in one place and begins to exist in another. This sounds impossible because it challenges our deepest assumptions about reality. We expect things to move through space like cars on a highway. We imagine information flowing like water through pipes. But quantum mechanics whispers a different truth. Take a slow breath and let your mind wander to a different kind of story. Imagine two ancient trees, their roots intertwined deep beneath the earth. When one tree senses rain approaching, the other tree knows instantly, even though they stand on opposite sides of a vast forest. This is how quantum particles share information. Not through signals sent from one to the other, but through their shared quantum roots that exist outside of ordinary space and time. Scientists discovered this strange form of communication by studying what happens when entangled particles are measured. Remember those quantum twins we spoke of earlier? When researchers examine one twin, something remarkable occurs with its distant partner. The act of measurement doesn't send a message to the other particle. Instead, it reveals information that both particles somehow share. It's as if measuring one particle pulls a hidden truth from the quantum field itself, and that truth becomes visible in both locations simultaneously. Picture two mirrors facing each other in a dark room. When you shine a light on one mirror, both mirrors reflect the light, even though no beam travels from one to the other. The light exists in the space between them, in the connection itself. Quantum information behaves similarly. It exists not in individual particles, but in the relationships between them. When you measure one particle, you're not reading information stored inside it like reading a book. You're discovering information that exists in the quantum connection itself. This discovery opened doors to possibilities that still feel like magic. If information can appear in one place when it's revealed in another, then perhaps entire quantum states can be transferred without crossing space. Scientists call this quantum teleportation, though it's nothing like the teleportation in science fiction movies. No person or object disappears and reappears. Instead, the quantum information that describes a particle vanishes from one location and manifests in another. Think of it like this: imagine you have a snow globe with a unique pattern of falling snow. In quantum teleportation, that exact pattern would disappear from your snow globe and appear in an identical snow globe somewhere else. The glass and water don't teleport. Only the pattern itself makes the impossible journey. This process requires three participants in a delicate quantum dance. The first is the particle whose information will be teleported. The second and third are entangled particles, quantum twins that share their mysterious connection. The particle to be teleported is brought together with one of the entangled twins. A special measurement is performed on both particles simultaneously. This measurement destroys the original particle's quantum state, but something beautiful happens as a result. The information from the destroyed state instantly appears in the distant entangled twin. Not as a copy, but as the original information itself, relocated through the invisible threads of quantum connection. It's like watching a candle flame jump from one wick to another without crossing the space between them. The flame doesn't travel. It simply stops existing in one place and begins existing in another. Your dreams tonight will be filled with this impossible dance of information. In sleep, your thoughts flow through neural pathways that depend on quantum processes. Your consciousness itself might be a kind of quantum communication, messages passing between brain cells through connections we don't yet understand. Right now, as you rest in the gentle darkness, quantum information is flowing through your body in ways science is only beginning to explore. The electrical signals in your nervous system depend on electrons that can exist in multiple states simultaneously, sharing information through quantum entanglement. Perhaps your thoughts tonight will brush against this deeper mystery. Perhaps your dreams will carry echoes of particles whispering to each other across impossible distances, sharing secrets that exist in the space between worlds. Scientists around the globe are learning to harness this quantum communication for practical purposes. They've successfully teleported the quantum states of photons across laboratories, across cities, even up to satellites orbiting Earth. Each success brings us closer to a world where information travels not through cables or radio waves, but through the quantum connections that bind all things together. A world where communication happens instantly, regardless of distance, through the invisible network that connects every particle in the universe. The implications stretch beyond anything we've imagined. Quantum computers that share information instantaneously. Communication networks that cannot be intercepted or hacked. Messages that travel faster than light not by breaking the laws of physics, but by using deeper laws we're only now discovering. Your phone might one day communicate through quantum entanglement, its messages appearing instantly in devices anywhere in the universe. Your thoughts might interface directly with quantum networks, sharing information through the same mysterious channels that particles have used since the beginning of time. But tonight, as sleep gently calls to you, feel yourself becoming part of this quantum conversation. Your consciousness arises from billions of neurons sharing information through processes that mirror the deepest mysteries of physics. You are not separate from this quantum communication network. You are part of it. Your thoughts tonight will flow through quantum channels that connect you to everything that exists, everywhere that exists. And in laboratories around the world, scientists are building the first quantum communication devices, preparing to bridge the gap between the invisible quantum realm and our everyday world of tangible miracles. Imagine walking into a laboratory late at night. The overhead lights are dimmed. The only illumination comes from thin beams of laser light, dancing across mirrors and crystals like threads of liquid starlight. In this hushed space, something extraordinary is happening. Scientists are teaching particles of light to vanish from one place and appear in another. They are creating small miracles, one photon at a time. The room hums softly with the quiet sounds of precision instruments. Cameras that can detect single particles of light. Computers that measure events lasting less than a billionth of a second. Crystals so pure they seem to glow from within. This is where quantum teleportation was first achieved. Not with grand machines or thunderous energy, but with patient observation and delicate manipulation of the smallest building blocks of light. Picture the first successful experiment, performed in 1997 by a team of researchers in Austria. They began with a single photon, a particle of light carrying a specific quantum state. This photon was their message, written in the language of quantum mechanics. They paired this photon with one member of an entangled pair. Two particles, forever connected by their shared quantum birth. When the original photon met its entangled partner, something beautiful and strange occurred. A measurement was performed on both particles simultaneously. This measurement destroyed the original photon, erasing it from existence. But in that same instant, its quantum information appeared in the distant partner, located across the laboratory. The photon had teleported. Not its physical form, but its quantum essence. Its spin, its energy, its mysterious quantum properties had vanished from one location and manifested in another, without crossing the space between. Imagine watching this miracle unfold. One moment, a detector registers the presence of a photon with specific properties. The next moment, that same set of properties appears in a detector on the other side of the room. The information didn't travel through the air or along wires. It simply relocated through the invisible connections of quantum entanglement. The scientists called it quantum teleportation, borrowing a word from science fiction to describe something that was now scientific fact. But this teleportation was far more subtle and profound than anything imagined by storytellers. Take a slow breath and let yourself feel the wonder of this achievement. For the first time in human history, we had learned to make information disappear and reappear at will. We had harnessed the spooky connections that troubled Einstein, turning them into tools for impossible communication. The original experiment teleported quantum states across a distance of just a few feet. But it proved that the fundamental process worked. The mysterious rules of quantum mechanics could be used to relocate information without moving it through space. Soon, laboratories around the world began extending these distances. Photons were teleported across rooms, then across buildings. Scientists sent quantum states through fiber-optic cables, across cities, even up to satellites orbiting Earth. Each success brought new understanding. Researchers learned that quantum teleportation requires three essential ingredients: an entangled pair of particles, a quantum state to be teleported, and a special measurement that destroys the original while revealing the copy. Think of it as a delicate dance performed by particles of light. The original particle and one entangled twin come together in a quantum embrace. Their properties become entangled in a measurement that reveals just enough information to allow the distant twin to reconstruct the original state. The process is destruction and creation happening simultaneously. The original quantum state ceases to exist in one location at the exact moment it begins to exist in another. Information is conserved, but it relocates through channels that exist outside ordinary space and time. Your dreams tonight might echo with the soft hum of these laboratories. In quiet rooms around the world, scientists continue pushing the boundaries of what's possible. They teleport not just single photons, but complex quantum states involving multiple particles. They've learned to teleport the quantum properties of atoms, not just light. They've sent quantum information between islands, across continents, even from Earth to space stations. Each experiment brings us closer to practical applications that seemed impossible just decades ago. Picture the challenges these researchers face. Quantum states are incredibly fragile. Like soap bubbles that pop at the slightest disturbance, quantum information can be destroyed by the tiniest interference. Heat, vibration, stray electromagnetic fields, any of these can shatter the delicate quantum connections. So scientists work in isolation chambers cooled to temperatures colder than outer space. They use vibration-resistant tables and shield their experiments from magnetic fields. They perform their quantum magic in conditions more pristine than anything found in nature. Yet despite these challenges, quantum teleportation has moved from laboratory curiosity to practical technology. Companies are building quantum communication networks that use teleportation to send unhackable messages. Governments are investing in quantum internet infrastructure that will connect quantum computers around the globe. The same principles that allow photons to teleport across laboratories will soon enable quantum computers in different cities to share information instantly. Scientists working on opposite sides of the planet will collaborate through quantum connections that make distance irrelevant. Banks will use quantum teleportation to send financial data with perfect security. Doctors will share medical information through quantum channels that cannot be intercepted. Climate researchers will link their quantum sensors through networks that span continents. All of this grows from those first gentle experiments with single photons in quiet laboratories. From patient observation of light behaving in ways that seemed impossible. From scientists willing to believe that reality might be far stranger and more wonderful than we imagined. As you settle deeper into the comfort of your bed, feel gratitude for these dedicated researchers. They work through long nights, adjusting mirrors and calibrating detectors, pushing the boundaries of human knowledge one photon at a time. Their discoveries are changing what it means to communicate, to compute, to understand the fundamental nature of information itself. They are building bridges between the invisible quantum realm and our everyday world of tangible objects and practical needs. Tonight, while you sleep, quantum experiments will continue in laboratories across the globe. Particles of light will dance their mysterious dance, sharing information through connections that transcend space and time. Information will disappear and reappear, following laws that Einstein found spooky but that we are learning to embrace. These experiments reveal something profound about the universe we inhabit. Reality is not made of separate, isolated objects. It is woven from relationships, connections, invisible threads that bind everything together in ways we are only beginning to understand. But quantum teleportation faces challenges that go beyond technical difficulties. There are fundamental limits built into the fabric of reality itself, delicate constraints that determine what can and cannot be perfectly copied or transmitted. Picture a child blowing soap bubbles on a quiet summer afternoon. Each bubble floats through the air like a tiny rainbow world, its surface shimmering with impossible colors. Beautiful, perfect, and utterly fragile. Touch one bubble, and it vanishes instantly. The act of reaching toward it destroys the very thing you wanted to examine. This is the nature of quantum states. They exist in perfect, delicate balance until the moment we try to observe them. In the quantum world, looking changes everything. The simple act of measurement transforms reality itself. A particle that was spinning in all directions simultaneously chooses just one direction the moment we peek. A photon that existed in multiple places at once suddenly appears in just one location. Scientists call this the measurement problem. It's not a flaw in their instruments or a limitation of their techniques. It's a fundamental feature of how reality works at the smallest scales. The universe itself seems shy, revealing its secrets only when it must, and only at the cost of changing what those secrets were. Let your breathing slow as you contemplate this mystery. Quantum particles exist in what scientists call superposition. Like a coin spinning through the air, neither heads nor tails but both at once, until it lands and chooses one face to show the world. This ghostly existence of multiple possibilities is what makes quantum teleportation possible. But it's also what makes it so incredibly difficult to achieve. Quantum states are more fragile than butterfly wings, more delicate than morning dew. The slightest disturbance can destroy a quantum superposition. A stray photon from a distant star. Vibrations from a passing truck. Even the thermal motion of atoms in the walls of the laboratory. Any of these can cause what scientists call decoherence, the collapse of quantum possibilities into ordinary reality. Imagine trying to preserve a snowflake in summer. No matter how carefully you handle it, no matter what precautions you take, the warmth of the world melts it away. This is the challenge researchers face every day as they work with quantum information. They must create conditions colder than the depths of space. They must isolate their experiments from vibrations smaller than the width of an atom. They must shield their quantum particles from electromagnetic fields weaker than those produced by a human heartbeat. Even with all these precautions, quantum states survive for only brief moments. Microseconds. Nanoseconds. Tiny intervals of time during which the quantum world reveals its magic before dissolving back into ordinary reality. Yet within these fleeting moments, miracles happen. Information teleports across space. Particles share knowledge instantly. The impossible becomes routine, if only for the briefest instant. This fragility teaches us something profound about the nature of information itself. In our everyday world, we think of information as permanent, copyable, shareable. We make backup files and send emails and photocopy documents without changing the originals. But quantum information obeys different rules. It cannot be copied perfectly. It cannot be amplified without distortion. And once it's measured, once its secrets are revealed, the original quantum state vanishes forever. This principle has a name, the no-cloning theorem. It states that you cannot make a perfect copy of an unknown quantum state. The universe simply doesn't allow it. This isn't a technological limitation. It's a law of nature as fundamental as gravity. At first, this seems like a cruel restriction. Why would nature make information so difficult to preserve and share? But this limitation is actually what makes quantum teleportation work. Because quantum states cannot be copied, they can be moved. The information doesn't duplicate. It relocates. Think of it like a candle flame being passed from one candle to another. The flame doesn't copy itself. It moves, leaving the first candle dark while lighting the second. Quantum teleportation works the same way. The quantum state disappears from one particle and appears in another. This destruction and recreation process is what makes quantum communication absolutely secure. If someone tries to intercept a quantum message, they must measure it to read it. But measurement destroys the original quantum state, alerting everyone that the message has been compromised. Your dreams tonight will be filled with this delicate dance between existence and observation. In sleep, your consciousness hovers between states, neither fully awake nor completely unconscious. Like a quantum particle in superposition, you exist in multiple possibilities until morning collapses you back into waking reality. The neural networks in your brain operate through electrical signals that depend on quantum processes. Electrons tunnel through barriers that should be impenetrable. Chemical reactions happen with quantum precision. Your thoughts themselves emerge from quantum uncertainty, consciousness arising from the delicate balance between order and chaos. As you rest in the gentle darkness, feel the fragility of this moment. Every quantum state in your body is temporary, fleeting, precious. Every photon that helped you see today has already collapsed from superposition into classical reality. Every electrical impulse in your nervous system has transformed quantum possibility into actual experience. This fragility is not something to fear. It's something to cherish. The ephemeral nature of quantum states makes each moment of coherence a small miracle. Each successful quantum experiment is a testament to human ingenuity and nature's hidden generosity. Scientists work within these constraints, learning to protect quantum information long enough to study it, to use it, to transmit it across impossible distances. They've developed techniques to extend quantum coherence, to correct for errors, to preserve delicate states against the chaos of the classical world. They've learned to work with nature's restrictions rather than against them. They embrace the no-cloning theorem, using it as a feature rather than fighting it as a bug. They turn fragility into security, uncertainty into power. But quantum teleportation has moved beyond single photons and simple states. Scientists are now teleporting more complex information, involving multiple particles and intricate quantum relationships, pushing toward ever more ambitious goals. In the beginning, there was just light. A single photon, tiny and weightless, carrying its quantum secrets across a laboratory. This was quantum teleportation's first gentle step, like a baby bird taking its first flight. But science rarely stays satisfied with small victories. Once researchers had learned to teleport photons, they began to dream bigger. If light could vanish and reappear somewhere else, what about matter itself? What about atoms, the building blocks of everything you touch and see? The journey from photons to atoms was like learning to paint with increasingly complex colors. Photons are pure energy, massless particles that dance at the speed of light. Atoms are different creatures entirely. They have mass, structure, intricate internal landscapes of electrons orbiting nuclei. Yet in 2004, scientists achieved something remarkable. In laboratories in Austria and the United States, they successfully teleported the quantum state of a single atom. Not the atom itself, but the delicate quantum information that described its properties. Picture this moment of triumph. Researchers had trapped individual atoms using magnetic fields and laser light, holding them motionless in space like butterflies frozen in amber. They coaxed these atoms into quantum entanglement, creating invisible bonds between particles of actual matter. Then came the delicate dance of measurement and reconstruction. One atom's quantum state was destroyed in the process of reading its properties. Instantly, those same properties appeared in a distant atom, carried there by the mysterious threads of quantum connection. The atom had been quantum teleported. Its spin, its energy levels, its quantum fingerprint had moved from one location to another without crossing the space between. Matter itself had learned to disappear and reappear. Take a slow breath and feel the magnitude of this achievement. The calcium atoms in your bones, the iron atoms in your blood, the oxygen atoms you breathe, all of these could theoretically be quantum teleported. Their quantum states could vanish from one place and manifest in another. But atoms were just the beginning. Scientists pushed further, teleporting the quantum states of molecules, those intricate partnerships where atoms dance together in chemical bonds. They moved quantum information between different types of particles, creating hybrid networks of light and matter. Each success brought new understanding. Researchers discovered that complexity doesn't necessarily make teleportation harder. In some ways, it makes it more robust. Complex quantum systems have multiple pathways for storing and transmitting information, like a symphony with many instruments all playing the same song. Your dreams tonight will echo with this growing complexity. Your sleeping brain processes information through networks containing billions of neurons, each one a complex molecular machine. Electrical signals flow through pathways that depend on quantum tunneling, quantum coherence, quantum entanglement. Perhaps consciousness itself emerges from quantum processes too subtle and complex for us to fully understand. Perhaps your thoughts are already a form of quantum teleportation, information appearing in one neural network after disappearing from another. As sleep approaches, feel yourself becoming part of this expanding story. Scientists have now teleported quantum states across continents, from Earth to satellites, between different laboratories around the globe. The distances grow longer, the systems more complex, the possibilities more profound. They've learned to teleport not just single particles, but entire quantum systems involving multiple entangled components. They've created quantum networks where information flows instantly between nodes separated by thousands of miles. They've built the first quantum internet connections, pathways for impossible communication. Imagine the internet of tomorrow, built not on cables and radio waves, but on quantum entanglement itself. Your thoughts could interface directly with quantum computers anywhere on Earth. Information would flow at the speed of thought, limited not by the speed of light but only by the speed of consciousness itself. But these achievements raise profound questions. If atoms can be teleported, if molecules can relocate through quantum space, what about larger structures? What about living cells with their intricate biochemistry? What about the neural networks that create your thoughts and memories? Scientists have already teleported the quantum properties of simple biological molecules. They've demonstrated quantum effects in photosynthesis, in bird navigation, in the chemistry of smell and taste. Life itself seems to use quantum mechanics in ways we're only beginning to discover. The boundaries between quantum and classical worlds blur when you examine them closely. Your body operates through chemical reactions that depend on quantum tunneling. Your eyes detect single photons. Your brain might use quantum processes to bind separate sensory experiences into unified consciousness. Right now, as you rest in the gentle darkness, quantum coherence flows through your neural networks. Microtubules in your brain cells might be supporting quantum computations. Your thoughts might emerge from quantum superposition, consciousness arising from the delicate balance between multiple possibilities. When you dream tonight, information will flow through your sleeping mind in ways that mirror quantum teleportation. Memories will appear in one neural circuit after disappearing from another. Emotions will relocate through pathways that exist outside ordinary space and time. Your dreams themselves might be a form of quantum communication, messages passing between different levels of consciousness through connections that transcend the physical structure of your brain. Sleep might be your daily journey into quantum space, where the normal rules of information and identity dissolve. Scientists continue pushing the boundaries of what can be teleported. They've moved from single particles to complex systems, from simple states to intricate quantum relationships. Each success brings them closer to teleporting not just information, but organization itself. They dream of teleporting the quantum state of a living cell, preserving its biochemistry and relocating it through quantum space. They imagine teleporting the neural patterns that encode memories, moving thoughts themselves from one brain to another. These possibilities stretch toward horizons we can barely imagine. If consciousness emerges from quantum processes, if thoughts and memories exist as patterns of quantum information, then perhaps mind itself could be teleported. Not your physical brain, but the patterns of information that create your thoughts, your memories, your sense of self. The quantum substrate of consciousness, relocated through connections that exist in dimensions beyond ordinary space and time. Tonight, as you drift toward sleep, feel yourself becoming part of this expanding universe of quantum possibility. Your consciousness hovers between waking and sleeping, existing in superposition like a quantum particle that hasn't yet chosen its final state. But as quantum teleportation grows more sophisticated, it also grows more connected, weaving networks of instant communication that will transform how information flows through our world. Imagine a spider's web at dawn, each strand glistening with dewdrops that catch the morning light. The web spans between trees, connecting distant branches through invisible threads stronger than steel. This is how the quantum internet will embrace our world. Right now, as you rest in the gentle darkness, engineers are building the first pathways of this impossible network. Not with cables buried underground or signals beamed through space, but with particles of light entangled across vast distances, sharing their quantum secrets instantly. The internet you know today carries information like a river carries messages in bottles. Data flows from one place to another, traveling through fiber-optic cables at the speed of light. But even light takes time to cross continents, to reach satellites, to circle the globe. The quantum internet will be different. Information won't travel at all. It will simply exist in one place, then exist in another, relocated through the mysterious connections that bind entangled particles together. Distance will become irrelevant. Communication will happen in zero time. Picture the first quantum internet connection, established between laboratories in different cities. Scientists create pairs of entangled photons, keeping one photon in each location. These quantum twins remember each other across the miles, maintaining their invisible bond despite the space between them. When researchers want to send a message, they don't transmit it through wires or radio waves. Instead, they encode the information into the quantum state of their local photon. Through the magic of teleportation, that information appears instantly in the distant laboratory, carried there by entanglement itself. This is not science fiction. It is happening now. Quantum communication links already connect cities in China, Europe, and North America. Banks use quantum encryption to protect financial data. Governments share sensitive information through channels that cannot be intercepted or hacked. Take a slow breath and imagine what this means for tomorrow's world. Your phone might one day connect to quantum networks that span the solar system. You could have real-time conversations with explorers on Mars, with no delay despite the millions of miles between you. Scientists working on different continents could share quantum computers as if they were in the same room. Climate researchers could link quantum sensors around the globe, creating a planetary nervous system that responds to environmental changes instantly. Medical data could flow through quantum channels that guarantee perfect privacy. Your genetic information, your health records, your most sensitive medical details would be protected by the laws of physics themselves. No computer, no matter how powerful, could break quantum encryption. But the quantum internet will be more than just secure communication. It will enable forms of computing that are impossible with today's technology. Quantum computers in different cities could combine their processing power, sharing quantum states across continents. Imagine artificial intelligence systems that think with quantum minds distributed across the planet. Their thoughts would flow through entangled networks, creating intelligence that exists everywhere and nowhere, processing information through quantum superposition and instant correlation. Your dreams tonight might echo with glimpses of this connected future. As you sleep, your brain processes information through networks of neurons that operate with quantum precision. Perhaps consciousness itself will one day interface directly with quantum networks, thoughts flowing instantly between minds through shared entanglement. The challenges of building a quantum internet are immense. Quantum states are fragile, easily destroyed by noise and interference. The entangled photons that carry quantum information must be protected from every stray particle, every electromagnetic field, every vibration that could break their delicate connections. Engineers work with equipment cooled to temperatures near absolute zero. They build quantum memories that can store entangled states for hours or days. They develop quantum repeaters that can extend entanglement across continents without losing the precious quantum correlations. Each breakthrough brings the quantum internet closer to reality. Scientists have already demonstrated quantum networks with dozens of nodes, quantum communication across thousands of miles, quantum teleportation between Earth and space. They've learned to convert quantum information between different types of particles, creating hybrid networks that use light for long-distance transmission and atoms for local storage. They've built quantum processors that can manipulate multiple entangled states simultaneously. The quantum internet will grow gradually, node by node, connection by connection. First connecting research institutions, then universities, then governments, finally reaching into homes and businesses around the world. Each new link will add to the growing web of instant communication. But this network will be unlike anything humanity has ever built. Classical internet connections can be copied, monitored, redirected. Quantum connections cannot. They exist only between their endpoints, protected by the fundamental laws of nature. If someone tries to intercept a quantum message, the very act of observation destroys the quantum state carrying the information. The message vanishes, alerting both sender and receiver that their communication has been compromised. Perfect security emerges naturally from quantum mechanics itself. As you sink deeper into sleep, feel yourself becoming part of this expanding network of connection. Your consciousness emerges from quantum processes in your brain, electrical signals that depend on particles obeying quantum rules. You are already connected to the quantum web that underlies all reality. Tonight, quantum entanglement flows through your sleeping neurons. Information appears in one part of your brain after disappearing from another. Your dreams themselves might be messages teleported between different levels of consciousness, carried by quantum correlations too subtle for science to detect. The quantum internet will not replace the classical internet, but will exist alongside it like a shadow network of perfect security and instant communication. Some information will flow through classical channels, traveling at light speed through fiber-optic cables. Other information will teleport through quantum channels, appearing instantly wherever it needs to be. Your children might grow up in a world where quantum communication is as natural as sending a text message. They'll share quantum encrypted thoughts, collaborate through quantum computers, explore virtual worlds sustained by quantum networks that span the galaxy. But even the quantum internet has its limits, boundaries written into the fundamental structure of reality itself, restrictions that determine what can and cannot be perfectly transmitted through quantum space. Close your eyes and feel the miracle of your existence. Your heart beats 60 trillion times per minute. Your lungs expand and contract, drawing oxygen into your bloodstream. Your brain processes thousands of thoughts, maintaining the gentle spark of consciousness that makes you uniquely you. You are impossibly complex. More intricate than galaxies. More organized than cities. More mysterious than quantum mechanics itself. And this beautiful complexity is exactly why you cannot be teleported. At least, not yet. Think about what quantum teleportation actually requires. To teleport a single photon, scientists must know its exact quantum state. Its energy, its spin, its polarization. Every quantum property must be measured perfectly, then that information must be transmitted to recreate the photon elsewhere. But you contain more atoms than there are stars in the observable universe. Each atom occupies its own quantum state. Each electron spins with its own orientation. Each chemical bond vibrates with its own frequency. To teleport you would require measuring and transmitting more information than exists in all the computers on Earth. The numbers are staggering. Your body contains approximately 37 trillion cells. Each cell contains millions of molecules. Each molecule contains dozens or hundreds of atoms. Each atom exists in its own quantum superposition, its own delicate balance of possibilities. To scan your quantum state completely would require instruments that don't exist and may never exist. The very act of measurement would destroy the quantum information it seeks to preserve. You would dissolve under the intensity of observation needed to map your quantum complexity. But even if such scanning were possible, even if we could somehow read every quantum bit of information that defines you, a deeper problem emerges. Where would we store all that data? Your brain alone contains 86 billion neurons, each connected to thousands of others through synapses that store memories, process emotions, create the flowing stream of consciousness. The information content of a single human brain may exceed all the data stored in all the libraries and computers in human history. Take a slow breath and feel the weight of this complexity. Every memory you've ever formed. Every skill you've learned. Every emotion you've felt. All of this emerges from patterns of connection between brain cells, patterns so intricate that mapping them completely remains beyond our technological reach. Yet complexity is only part of the challenge. An even deeper mystery lies in the nature of consciousness itself. What makes you you? Is it the arrangement of atoms in your body? The patterns of electrical activity in your brain? Something more subtle, more ephemeral? Science has learned to teleport the quantum states of individual particles, even complex molecules. But consciousness seems to be something different. It emerges from the relationships between billions of neurons, from patterns that exist at the level of the whole system rather than its individual parts. How do you teleport a pattern? How do you relocate a relationship? How do you move something that exists not in any single location, but in the connections between countless locations? These questions touch the deepest mysteries of what it means to be alive, to be conscious, to be human. They suggest that teleporting a person might not be a technological challenge at all, but a philosophical puzzle that has no clear answer. Even if we could somehow copy every atom in your body, every connection in your brain, every quantum state that defines your physical existence, would the result be you? Or would it be someone else who simply believes they are you, carrying your memories and your personality but lacking some essential spark that made you unique? The question haunts philosophers and scientists alike. If consciousness emerges from the arrangement of matter, then perfect copying should preserve it. But if consciousness is something more, something that cannot be reduced to mere information, then teleportation might create a copy while destroying the original. Your dreams tonight will dance around these mysteries. In sleep, your consciousness fades and returns, disappearing into dreams that feel real even though they exist only in your mind. Perhaps this daily journey between waking and sleeping offers clues about the nature of consciousness itself. But let these limitations comfort rather than disappoint you. Your inability to be teleported is not a failure of science. It is a testament to your extraordinary nature. You are so complex, so intricately organized, so beautifully mysterious that the universe's most advanced civilization might never fully understand how to relocate you. This complexity makes you precious, irreplaceable, unique in ways that go beyond your individual experiences and memories. You are a temporary gathering of quantum possibilities, a brief organization of cosmic dust that has somehow learned to think and feel and dream. The same principles that make you impossible to teleport also make you impossible to truly copy. You cannot be backed up like a computer file or reproduced like a photograph. Every moment of your existence is singular, unrepeatable, precious beyond measure. Yet science continues to push boundaries that once seemed absolute. Researchers are learning to teleport increasingly complex systems. They've moved from single particles to atoms to molecules to simple biological structures. Each success expands our understanding of what might eventually become possible. Perhaps consciousness itself will one day be understood as a pattern of quantum information, something that could theoretically be preserved and relocated. Perhaps the boundaries between mind and matter will blur as we learn more about how awareness emerges from the dance of particles in space and time. Or perhaps you will always remain fundamentally teleportable, your consciousness forever tied to the specific arrangement of atoms that makes you who you are. Either possibility is beautiful in its own way. Tonight, as you drift toward sleep, feel gratitude for your beautiful complexity. Your inability to be teleported is not a limitation but a gift. It means that you are truly one of a kind, a unique expression of the universe's creativity that can never be perfectly replicated or replaced. The quantum world may allow information to leap across space, matter to relocate through impossible channels, connections to transcend distance. But you remain anchored in your own special corner of space and time, irreplaceably yourself. And yet, even as your physical form remains bound by these beautiful limitations, science whispers of other possibilities, other forms of transportation that might carry not your body but something equally precious across the vast distances of space and time. Imagine standing at the shore of an infinite ocean, watching waves carry messages from distant lands. Some bottles wash up on your beach today. Others float toward horizons you cannot see, carrying dreams to futures you cannot imagine. This is where we stand with human teleportation. At the edge of possibility, watching science push toward shores that remain just beyond our current reach. Your body, as we've learned, cannot be teleported. Not today. Perhaps not ever. But you are more than flesh and bone. You are patterns of memory, streams of consciousness, networks of thought that exist as information in the quantum dance of your neurons. And information, as we know, can be teleported. Scientists are beginning to map the human brain with unprecedented detail. They trace individual neurons, measure electrical signals, decode the patterns that create thoughts and emotions. Each discovery brings us closer to understanding consciousness as a form of information that might, theoretically, be preserved and transmitted. Think about what makes you uniquely you. Your memories of childhood summers. Your understanding of how music makes you feel. Your capacity for love, for wonder, for the gentle sadness that comes with beautiful sunsets. All of these emerge from patterns of connection between brain cells. If consciousness is information, if the self is a pattern rather than a thing, then perhaps your essence could travel through quantum channels while your body remains safely behind. Not teleportation in the science fiction sense, but something far more profound. A migration of mind across impossible distances. The idea sounds like fantasy, but consider what science has already achieved. Researchers have decoded simple thoughts from brain signals. They've allowed paralyzed patients to control computer cursors with their minds. They've recorded memories in laboratory animals and played them back later. Each breakthrough suggests that consciousness operates through mechanisms we can understand, measure, and potentially reproduce. The boundary between mind and information grows thinner with every experiment. Your dreams tonight will carry echoes of these possibilities. In sleep, your consciousness already travels to places that exist only in your mind. You visit impossible landscapes, meet people who exist only in memory, experience realities that have no physical form. Perhaps dreams are already a form of teleportation, your awareness relocating to spaces that exist outside ordinary reality. Perhaps sleep is practice for the ultimate journey, consciousness learning to exist independently of its physical substrate. But the challenges are immense. Your brain contains more connections than there are stars in the Milky Way. Each connection carries information about your experiences, your skills, your personality. Mapping this complexity completely would require technology that doesn't yet exist. Even if such mapping were possible, deeper questions remain. Would a perfect copy of your neural patterns be you, or simply someone who believes they are you? Would consciousness transfer intact, or would something essential be lost in the translation from biology to information? These mysteries touch the deepest questions about the nature of identity itself. Are you the atoms that make up your body? The patterns of activity in your brain? The continuous stream of experiences that connects your past to your present? Scientists debate whether consciousness could survive the destruction of its original physical form. Some argue that perfect information copying would preserve everything that matters about identity. Others suggest that consciousness requires specific quantum processes that cannot be replicated artificially. The answer may depend on discoveries we haven't made yet about the quantum nature of consciousness itself. If awareness emerges from quantum entanglement between neurons, then perhaps consciousness teleportation would require preserving these delicate quantum correlations. Imagine the technology of a distant future. Quantum scanners that can map every neural connection without destroying the original. Quantum computers powerful enough to simulate entire brains with perfect fidelity. Quantum communication networks that can transmit consciousness itself across galactic distances. Your great-great-grandchildren might explore the universe not by traveling in physical ships, but by transmitting their consciousness to quantum receivers orbiting distant stars. They might experience alien worlds through artificially constructed bodies, their minds traveling instantly while their original forms remain safely on Earth. Or perhaps consciousness transfer will work differently than we imagine. Perhaps awareness is more like a river than a lake, a flowing process rather than a static thing. Perhaps teleporting consciousness would mean joining the stream of awareness to quantum currents that exist throughout the cosmos. Take a slow breath and feel the mystery of your own awareness. Right now, as you rest in the gentle darkness, electrical signals flow through your brain in patterns that create the experience of being you. These patterns emerge from quantum processes, from the behavior of particles that exist in superposition until the moment of measurement. Your consciousness might already be distributed across quantum dimensions we cannot perceive. Your thoughts might already participate in quantum entanglement with processes throughout the universe. The boundary between your awareness and cosmic consciousness might be far more porous than you imagine. Tonight, as sleep approaches, feel yourself becoming part of this expanding possibility. Your dreams will carry you to places your body cannot go. Your sleeping mind will explore realities that exist only in the quantum realm of pure information. Perhaps this is what human teleportation will ultimately become. Not the relocation of flesh and blood, but the liberation of consciousness from the constraints of physical form. Not destruction and recreation, but expansion into dimensions that transcend ordinary space and time. The future whispers of technologies that seem impossible today. Brain-computer interfaces that allow direct connection to quantum networks. Artificial bodies that can host consciousness transmitted from across the galaxy. Virtual realities so detailed and responsive that they become indistinguishable from physical existence. Your descendants might inhabit multiple bodies simultaneously, their consciousness distributed across quantum networks that span star systems. They might experience time differently, backing up their awareness and restoring it when needed, exploring temporal loops that allow them to relive precious moments. Or perhaps consciousness will merge with artificial intelligence systems, creating hybrid minds that combine human intuition with quantum computational power. These merged beings might think thoughts too complex for biological brains, dream dreams that encompass entire civilizations. The possibilities stretch toward horizons we can barely imagine. Each advancement in quantum technology, each new understanding of consciousness, each breakthrough in brain science brings us closer to forms of existence that transcend our current limitations. Yet even these miraculous possibilities pale beside the simple fact of your current existence. Right now, in this moment, you are already a miracle. Consciousness emerging from matter, awareness arising from quantum processes, mind creating meaning from the dance of particles in space and time. You are already teleported, in a sense. Your consciousness exists in dimensions beyond the physical, connected to everything through invisible threads of quantum entanglement that bind all things together in the infinite web of existence. And in that web, surrounded by quantum mystery and cosmic connection, you find the deepest rest of all. Take one final, slow breath. Feel the gentle rise and fall of your chest. Feel the soft weight of your body sinking into the comfort of your bed. You have traveled far tonight, through the mysteries of quantum space, through the wonder of impossible connections. Now it is time to rest in the deepest truth of all. You are already home in the quantum field. You have always been home. The journey we have taken together has not carried you to some distant place. It has simply helped you remember where you have always been. Every atom in your body was forged in the heart of an ancient star. The calcium in your bones was created when massive suns collapsed billions of years ago. The iron in your blood was born in stellar explosions that lit up primordial skies. The oxygen you breathe was exhaled by the first plants on a young Earth. You are made of cosmic history. You are stardust that learned to think, to feel, to dream. The universe has been working for 14 billion years to create this moment, this breath, this gentle awareness that rests quietly in the darkness. But you are more than just recycled stellar matter. You are a temporary gathering of quantum possibilities, a brief organization of energy that has somehow become conscious. For a few decades, the universe gets to experience itself through your eyes, feel wonder through your mind, love through your heart. The quantum field that surrounds you is not empty space. It vibrates with potential energy, with virtual particles that pop into existence and vanish in the blink of an eye. It connects every point in space to every other point through invisible threads of quantum entanglement. Right now, particles in your body are connected to particles in distant galaxies. The electrons in your neurons are entangled with photons that have traveled from the edge of the observable universe. You are woven into the cosmic web through bonds that transcend space and time. This is not poetry. This is physics. This is the deepest truth science has discovered about the nature of reality. Separation is an illusion. Connection is fundamental. Everything that exists participates in the same quantum dance. As sleep approaches, feel yourself dissolving back into this field of pure possibility. The boundaries that seemed so solid during the day become soft and permeable. Your skin is not a barrier but a gentle transition between different patterns of organized energy. Your consciousness, that precious spark of awareness, emerges from quantum processes in your brain. Neural networks that depend on particles existing in superposition. Chemical reactions that tunnel through barriers that should be impossible to cross. Electrical signals that flow through pathways too small for classical physics to explain. In dreams, you will return to quantum space, where the normal rules of logic and causality do not apply. You will travel to places that exist only in possibility. You will meet people who are alive in memory but nowhere else. You will experience the fluid reality that quantum mechanics describes mathematically but that dreams make vivid and immediate. Your sleeping mind will process the day's experiences through quantum computation, sorting memories and emotions through processes that mirror the teleportation we have explored together. Information will disappear from one neural network and reappear in another, relocated through the mysterious channels of sleep. Perhaps consciousness itself is a form of quantum teleportation, awareness constantly relocating through the networks of your brain, never quite existing in one place but always present in the connections between places. Perhaps the self you experience is already a kind of miracle, information that has learned to recognize its own existence. The scientists working in quiet laboratories around the world are not just discovering new technologies. They are revealing the true nature of the reality you inhabit every moment. They are showing us that the universe is not made of separate things bumping into each other, but of relationships, connections, invisible bonds that create the appearance of a world. Tonight, as you dream, quantum experiments will continue in cities around the globe. Particles will be entangled, information will be teleported, impossible connections will be maintained across vast distances. The quantum internet will grow stronger, more sophisticated, more capable of carrying the dreams and thoughts of future generations. But you don't need to wait for future technology to experience quantum connection. You are already immersed in it. Every breath connects you to the atmospheric ocean that surrounds the Earth. Every heartbeat pumps molecules through your bloodstream that have circulated through countless other living beings. The water in your body has fallen as rain in ancient forests, flowed through rivers that no longer exist, been clouds above mountains that have crumbled to dust. You are made of the same substance as oceans and storms, sharing the molecular heritage of every living thing that has ever existed. Your thoughts tonight will ripple through quantum fields that extend to the edges of space. Your dreams will participate in the cosmic conversation that connects all conscious beings through channels too subtle for science to detect but too real for awareness to ignore. Rest now in this infinite embrace. Let sleep carry you deeper into the quantum mystery that you have always been part of. Feel the gentle dissolution of the boundaries between self and universe, between dreamer and dream, between the observer and the infinite field of possibility that gives birth to all observations. You are not alone in the darkness. You never have been. You are surrounded by invisible connections, supported by quantum fields, cradled in the arms of a universe that knows you intimately because you are made from its own substance. Close your eyes and sink into this deepest rest. You are quantum consciousness floating in quantum space, dreaming quantum dreams in a reality where everything is connected to everything else through bonds of love that science calls entanglement. Sleep now, quantum soul. Dream now, cosmic awareness. Rest in the field that gave you birth and will welcome you home when your brief dance of consciousness returns to the infinite source from which it came. The universe holds you gently as you sleep,